Alright, today I'm going to show you how to derive the arc length formula that is used in calculus to measure the length of a line or a graph. So first I'm going to write our axis, and I'm just going to draw a general line, and this will be called f of x. Okay, so if we were to look at a singular point, if we wanted to find the length at that point, we can look at it like this. So imagine this is an infinitesimally small triangle. And I know that's where it gets confusing, but this is just how you need to think about it. So on this triangle, if we wanted to find this length right here on the triangle, we can call that dl. We could call this dy, and we could call this dx. So now we can define dl equals dx. This is the Pythagorean theorem. So when I was taking calculus 2, I have bad memory, so I would write this almost every time, and then I would derive what I'm using. So sometimes they'll give you a function where it's f of x, where x is the independent variable, and sometimes they'll give you an equation where it is f of y, where y is the independent variable. So that's why I will show you later, there's two forms of this equation. So when we solve this further, obviously we're going like this. Okay. All right, so now that we're here, we need to have it so everything on this side is multiplied by either dy or dx. So because in this example, f is considered y and x is considered the independent variable, we can cancel x. So what we're going to do is we're going to multiply this side by dx over dx, which that equals 1. Okay, so how is this going to cancel? And what is going to cancel here? So we can think of dx equal to this. And when we think of it like this, we can look at this another way. All right. And so now we just distribute this in. So we only took this bottom portion right here. So I could have also wrote this like this, if it'll make it easier for some people. So that's another way to think about it. All right, so now we see that this is going to be 1. This is going to be dy over dx squared. So we could write that like this. And on the outside, dx. Right, so now we can evaluate this. And what that means is we're going to add up all of these infinitesimal components, and we're going to be left with L equals this integral. So if you look this up, this is the equation that you get for the arc length. But now, instead of memorizing it, you just need to know to use this triangle to find the arc length, or the infinitesimal arc length, dl. And then you cancel out whichever you're not using. So there's another, so this is, there's another one. So this is for f of x, if x is the independent variable. And the other one is if it is f of y. So that'll be so this may also look confusing. So I'm going to write this another way. So for this top one, we have 1 plus df over dx. And then for the bottom one, df dy. And that was an error, times dy. Okay, so for this one, this will be for f of x, because you're taking the derivative with respect to x. And this one will be f of y. So I know this can be a little confusing, but I hope this simplified it a little bit and you got some value out of this video. So thanks for watching. Have a good day. Goodbye.